Hello. So, hi, my name is JJ, and I am going to be spending this next couple hours playing around with a Kubernetes cluster that I am building from the ground up using um, Raspberry Pis. Now, this is truly live. I literally have just installed Raspbian on all four clusters, or oh, sorry, all four Raspberry Pis, and they are not clustered yet. I would take a picture of it, but unfortunately, I'm not quite great at. I don't have a camera. If you see right down there, that's where they are. Um, Hopefully, one day I'll get a better camera picture on it, so you can actually see it blinky blinky. But it is just four Raspberry Pis separated. My plan today is to install Kubernetes using something called k3s on it. And then I'm planning on doing some monitoring because I needed to get some monitoring as Kubernetes is running on it. Then I'm going to use another Kubernetes cluster in the IBM cloud with something called Razzie, where I'm going to get Razzie to start monitoring this Kubernetes cluster. This might actually be done tomorrow during another live stream with the virtual hackathon we have running. You should watch the IBM developer Twitch channel, which maybe I'm being retweeted or restreamed on, which would be pretty cool. But that's my plan. I'm gonna watch the Twitch stream or Twitch chat as best as I can. As you can keep seeing, I'm looking down to the left over here, mainly because that's my other monitor, and so I can actually see what's going on. And I have OBS running on there too, which is kind of fun. So I'm learning this as I'm going. Hopefully this will be useful for somebody, maybe in the future. And I'm recording this also, so I'm going to upload this to YouTube, so somebody can maybe watch that later, or hopefully it'll be useful for someone else. So let's go ahead and move over to the screen sharing here. So this is k3s. It's k3s.io. If you go to just K3, it's a Rancher Labs project where it is a easy to install binary, less than 40 megabytes, only running 512 megs of RAM to required to run. This is really cool because that's pretty much exactly what a Raspberry Pi can run. So we will just take in to install. I have these four Raspberry Pis right here. As you can see, the one's called Fitchner, the other one's called Mustang, one's called Darrow and Severo. Sorry. If you do not know, those are references to a or a book called The Red Rising. I'm not going to talk about The Red Rising. I just really like the series, and I was trying to think of four names apart from like K1 or K Node or something like that, and I was talking to my wife about it, and she was like, "You should name it after the characters from the book." If you don't know, Darrow is actually the main character, and it's actually quite funny how he's underneath Mustang. That's a nice little joke, and then Severo's underneath Darrow. That's kind of just an inside joke there. If you look at the way the cluster is set up, also Fitchner is the top one, Mustang is the middle one or second one, Darrow and Severo. I'm actually planning on adding a camera to Fitchner to do some viewing, and I actually have VNC running on Fitchner. If you can see this, I know it's quite small on my screen, but this is actually Fitchner, and one day I will have a camera attached to it where he'll take pictures and send them to the actual Kubernetes cluster, which was going to be Mustang, Darrow, and Severo. So let's give this a shot. First thing first, we need to actually install K3s. The actual documentation is very good. Rancher Labs has spent quite a bit of time making sure this is pretty much dead simple to run. And it's just a curl sh install. I know there's a lot of comments out there about why would you ever do this, but because this is just one binary, and also because these are ARM processors, running this on here would be next to simple. So I'm going to go here, right here, and Mustang is going to be my controller or leader node. So I'm going to install it on her first, Then I'm going to install it on Darrow here. And then I'm going to install it on Severo. I'm not going to actually install anything on Fitchner, just because it doesn't seem useful right now. I just need a leader node and 2 worker nodes for Kubernetes for that time. So I'm going to go ahead and close out Fitchner. But if you don't know, one cool thing about Tmux is the program I'm using here is you can actually evenly split these screens. So I can do select layout even vertical, and it'll make all 3 of them nice and, nice and even, which makes things great. All right. So, I chose k3s over something called micro k3s. If you look here, micro k8s, and I'll zoom in here. There's a lot of conversation going back and forth between these 2 Kubernetes clusters, these 2 Kubernetes deployments. One is micro k3s and the other is k3s. I realize that not everyone runs snaps and runs Ubuntu everywhere. Granted, the irony is I actually do run Ubuntu everywhere. But this one, I feel like there should be more out there that isn't just required to run on Ubuntu. So that's why I'm choosing k3s, because it's just a curl bash and just a binary and a Go file, a Go binary, instead of a snap install, which is micro k8s. I will say, though, that micro k8s is really good. It does the job extremely well. The team that runs it, and I've talked to them a handful of times now, and they really do have, if you are standardized on Ubuntu, I really strongly suggest spending some time with micro k8s or k3s. The team's great. They're really nice. And they're available at the Kubernetes Slack team under the micro k8s channel, I guess, is the right word. And it really does have all the things that it says. But again, like I said, I'm looking for something a little bit more out there, I guess is a good word for it. Or more supported for multiple operating systems. And Debian, granted, yes, Debian is the base for Ubuntu, but we're not going to get into that argument right now. But as you can see, Mustang's done here. Darrow is also done. Severo, because the way Severo is, he's always a little bit behind, which is another joke inside the book. But he is getting there. He's starting to start it, which is good. So what we'll see is we will run the k3s server on Mustang, just like we do have it here. And then I will have it running. I will take the node token from here, just from that quick start, as you can see down here. And then I will connect Darrow and Severo to it. And then I will actually be able to see if this actually works. I don't actually have DNS running, so I'm going to hard code the IPs. I probably shouldn't really do that in real life. But again, this is me playing with it in the real world to see how it goes. All right, so let's see here. And if you are actually watching this live, I appreciate it. I do have the stream chat open, or at least I should. I am trying to figure this out myself. And please ask questions or have any thoughts. Like I said, I'm trying to watch it while I'm typing these stuff out. All right, so first thing first, let's get Mustang up. So sudo k3s server failed to listen to that. That's not fun. Server already, it's already in use. pswx grep k3s kube cuddle get nodes. There we go. Okay, so that's good. The installation doesn't actually say that, so maybe if there's a way I can do a PR on this, because that is not right. That is really bad, actually. So cat So we need to see this node token right here, copy. So then cat, this guy should be, of course, sudo. So there we go, there's my node token. Yes, I know I realize I just put a token out on a stream, but that's not a big deal for me because I know these are not routable. I have no ways of getting to these machines, and if you really did want to add your worker node to my Kubernetes cluster, first of all, thank you for the compute power. That seems really dumb. And second, again, there's no way to get to these machines. They are very locked down. So we know for a fact IPA grep grep adder IPA. So the IP for this machine should be grep 92. There you go, 153. So I need to come over to Darrow now. Oops. And then I do pswx. So I need to stop Kubernetes. So that would be service k3s stop sudo pswx grep k3s. Still running. That'd be too easy. So let's see. Systemd system os grep k3. Let's call k3s service. Why is it not working? So we go back to here. Sudo system cuttle stop k3s. That's way too fast. k3s stop ps3s grep k3s. Nope. Alright. Good old Google. Stopping k3s. Maybe on the docks here. Still going, playing around with this. Click start. There's the server, joining nodes. I need to stop you. How do I stop you? Because knowing my luck, it's already started. Because I just want the agent running. Okay, stopping system D service. No. I can never remember this. Yeah. Oh, did I end it with service at the end? God damn it. Dot service. And then check status. Failed. Sudo reboot. I'm curious to see if it come back up. Because if it's auto rebooting, that's a problem. Sudo system cuttle stop k3s service. And there's the there's the thing again. There is Darrow. So if I go pswx grep k3s, Still running k3s get nodes or kubectl get nodes. It still looks, yeah, it's still going to the local one, so I don't want that. It's just in the edge didn't restart either. I would imagine if I was restarting the service, it would restart that too. How the hell does it stop the service? So if I do pswx grep ssh Darrow. Okay, so this is the actual Darrow machine again, so we're not sitting in those 2-3 different terminals. I can actually see what's going on here. Yes, grep server. There it is, local bin server k3s. So maybe there's a k3s stop? No. Help. Is there a... So, k3s server dash help? Oh, of course. Okay. Stop. Must be running as root. That's a good sign. Of course there's not. Help, grep, stop. No. Huh. So I don't want to have another, well, my theory here is I don't want to have another server. I don't want three servers running. I want them all to connect to one server. But as you can see, pswx grep k3s, as you can see, that's not helpful. Those are all agent stuff though, isn't it? Server. There we go. As you can see here, I do have the k3s server running, and I don't want it to run, so I need to disable. So here's running the server, and then to run the agent by default, then I disable the agent. So right now I have 3 Kubernetes clusters, 3 Kubernetes single node clusters. And I want to convert 2 of the ones in the worker nodes and 1 to be a server. So I'm assuming what I need to do on Mustang here is disable the agent on there, and then, but do you start the, it doesn't make any sense. Storage backends, no, I don't care about all that. So pswx grep see, if I go to the services, sudo cd etc systemd system user, no, that would be too easy. Find grep k3s system vi k3s service. Okay, so it takes an environmental variable here and it starts the server. Okay, so how do I don't want to start the server because, no, do I need to start the server? Because that's the binary, right? So the theory being, so I actually do need to, so that makes sense, right? So what I would actually have to do is k3s service, and then if I go back to, I need to change this to agent. Okay, that's why I did. Server of this guy at 192.168. What was it? 153. 6443 token of that ugly ass thing. Okay. Place that in. Okay. So my theory being, actually we'll do that. Sudo reboot. So the theory being now is that instead of starting the server, I just installed and started the agent, and I rebooted it and making sure that the service just starts the agent and connects it directly to Mustang. You know, connecting Darrow to Mustang. Oh, that's so cute. But let's see if that actually works. Right now, it's not blinking, which is... Oh, there we go. The network's come back up. So, let's see here. Mustang, K3s, kube, cuttle, get nodes. There we go. So we got it. So we got Mustang, which is the local one, and now Darrow sitting there. So what I'll do is I'll go over to Severo now and change Severo to the same thing that Darrow had. I'll just copy pasta it, I guess. And then dump that into the service and restart Severo. And then now I will have a 3-node Kubernetes cluster that I can actually start running things on that machine for. That's actually pretty cool. All right. So let's go back into Darrow. And then, yep. And then I need to do, of course, sudo cat etc systemd system k3s service, and I will take all of this, copy, put that in my box. Then I will go over to Severo, and then sudo su pi etc systemd system k3s service. I will delete and delete. If you don't know, I did capital D there. That deletes everything at the end of the line. It's a nice little Vim trick. Makes life a little bit easier. And then the 2Ds deletes things inside of Vim. I'm actually an Emacs user myself, just because I'm a nerd. But don't get me wrong, using Vim is also very nerdy. But you will discover very quickly, you will fall into one of those camps, assuming you can start to go down this path one day. So that's kind of fun. So there we go. So I will right quit out of this, and I will do reboot. And then if I come back over here, I don't need you anymore, and I don't need you anymore. So then I can do k3s kube cuttle get nodes watch. There we go. We should see Severo show up here in a second. Lights off. Lights off. So my theory here is now that we have a working 3-node Kubernetes cluster, right? Yes, there we go. There's Severo. He's up and running. So now I can, yep, and there's Mustang, and then there's Darrow. Perfect. Okay, so how do I get remote? There we go. This is what I need to do. Okay, so if I want to come over here and cat etc rancher k3s.yaml. Oh wow, that's a lot of information. Okay, so what I'll do is I will come to my local machine. Okay, and then I will go to cd.kube. So I have one here, so what I will do is I secure copy pi at Mustang / etc rancher k3s k3s.yaml to here. Oh, of course not. Sudo or ssh Mustang, and I will copy that to here. Make sure there's no weird ownership rules. There's not. Good. So I'll come back over here, And then I'll go to home, pi. Yes, I'm lazy, I'm sorry. Okay. Oh, by email, whatever. Okay, so then I will do, so I will do move k3s YAML to Raspberry or R Pi or k3s Pi cluster.yaml. Okay, and then I'll do copy k3s to config. Is that right? Okay. So then I'll come back out. Oh, that was dumb. So I'll bring this back up. View, zoom in. So kube, cuttle, get nodes. Huh. Oh, it's because I didn't change the localhost, right? vi or e config. No, it's kube config. Come on. There we go. I'm going to change localhost to Mustang. So then I come back over here, get nodes, and I should see 3. Just thinking about it. Thinking about it. Maybe? Please? No? Wow, that's interesting. Did I spell Mustang wrong? I might have. Yeah, SSH Mustang? No. Yes. SSH ping Mustang. Ah, it's because I don't actually have an IP address for it. Okay. So cat. Was it 153? No. Yeah, it was 53, wasn't it? Yeah. 192.168.1.153. Let's try that now. There we go. Okay, so now, as you can see from my local laptop, I can now talk to my 3-node Kubernetes cluster. It's perfect, right? Like that's really cool. So now I have a Kubernetes cluster running with k3s on my Raspberry Pis, which, in the grand scheme of things, that was a lot easier than it should have been. Should have been a lot harder than that. But I'm okay with this. So the next thing I'm going to do is I am going to probably start getting some monitoring on here. So what I'm going to do is I'm going to install probably Prometheus and InfluxDB, because I'm starting to feel real good about that, on Fitchner. And then with Fitchner, I'm going to do the node exporters for Severo, Mustang, and Darrow. So the theory being is that Fitchner, as a watcher, right, again, a joke about the book, I'll be able to go to Fitchner to see that, to make sure that these machines are in healthy states. I am all about trying to figure out any other good ideas here, but this feels right. I found a couple good tutorials already, just before starting viewing this. And looks like this guy right here has put together pretty much everything I need to do. So what I'm thinking is I'm going to go ahead and just bring up Fitchner here, install, like I said, Grafana and Prometheus on there, and then do the node exporter on these 3 boxes. So that's my theory. Let's see here. Okay, so Fitchner. I don't think I spelled his name right. I don't know. Whatever. So let's go ahead and install Prometheus on Fitchner. Prometheus is right here. And then I have Prometheus as a... Now this is not a 64-bit OS, or it's on AMD 64, so I believe I need the ARM installation of Prometheus, so maybe I should look that up. Prometheus, Raspberry Pi, and no, I'm not going to install the Docker stuff, Docker containers. I'm treating these machines like VMs, so my theory is these are quote-unquote bare metal, which will allow me to, you know, imagine these machines, and then I run Docker inside of the Kubernetes cluster. So I have a very clear line between the infrastructure and the application stack that I want to run. I will say, though, I haven't actually figured out what I'm going to be running inside of this Kubernetes cluster quite yet. That'll probably be another project inside of itself. And if you are watching this in the future, I am going to KubeCon APAC next week. Today is the July 19th. So I will be speaking there talking about open source stuff. And if you, for whatever reason, come across the stream or find the YouTube video after I post it and want to reach out, my contact info is pretty straightforward. It's just JJ Asgar, which is the name of the stream and all that on Twitter. And I really am trying to learn this stuff. And the best way for me to learn is either help you learn something new or find something out like I'm doing here and just walking through it. So this is me actually just really trying to figure this stuff out right now. I did not prepare apart from finding a couple websites because that's the best way to learn is to, do it. So let's see here. So these are all the node exporters again. I don't want the node exporter. I want the actual Prometheus. Oh, so he actually used the Prometheus cluster. Okay, or the Docker container. So we don't want that. We want to just download Prometheus directly to maybe it's on the releases over here. There's a Raspberry Pi. Oh, here we go. That seems better, right? Here we go. So I believe these are ARM 7s, but I'm not actually sure how to figure this one out. So check Raspberry Pi CPU ARM version. There we go. So how do I see what version I have? Perfect. Pretty straightforward. Cat proc CPU info. ARM 7. There we go. So as you can see, it's actually a quad core. Isn't that kind of cool? It's a quad core ARM 7 processor, which back in the day when I was first coming up into this world, the idea of having more than 2 processors was like $1,000-something. And now I'm sitting here on a $35 computer that has 4 cores, which is bonkers. I will say though, there is this one wonderful thing. If you look at top nowadays, you'll see the load average. So there's a lot of lies about load average, but the best way to remember load average is it's how many processes are running in the queue. And if you have 4 cores, that means in general, there's a lot of more math here and there's a lot of stuff, but the rule of the general rule is that means you can have a load average of 4 because there's 4 processors before things start having problems. So if you see a load average of like 30, divide that by 4, that means, or bad example, let's say 10 or 40, and divide that by 4, that means that there's 10 processes in queue waiting to be used for CPU time. This is a helpful kind of like just general rule when you start seeing really weird load averages, especially on multi-proc computers. A lot of times you don't have to worry about it nowadays because it's just the way it is. But it's just, if you're an old timer like me, it's just good to remember these kind of things. Okay, so we said we had a ARM 7. Yes. So let's go ahead and pull down the ARM 7 release here. So what I'll do is I'll use something called wget to pull this down. Wget right here. And it will go out to GitHub and pull it down. It's coming down pretty quick. And this is also just a Go binary, which is nice too. So what I will do inside of here, I will make a directory called Prometheus And I'm trying to do the best I can by having just my Baha'i user do all the work, not actually sudoing up to root unless I have to do something specifically on the machine, which is nice. So I will move Prometheus to 1 to Prometheus, there we go. So I will go into the Prometheus directory and I will do tar, what is it? It's cheesy, tar-xvzf Prometheus. Yes, I actually do remember the tar flags, believe it or not. That is a long story, but I can do those both at BZ2 and BZ2 and also TR without having to try to look at that one up, which is funny when you look at me looking up systemd commands, but for whatever reason, xvfzf has stuck with me. So there you go. So it's exporting Prometheus out to the machine. As you can see, there's a bunch of other stuff that comes along with it. But all we cared about was the actual Prometheus binary. So we go back to this guy. No, this guy. This guy. And then, oh, so he had already had the link down here. I just skipped ahead because in my mind, I should have Prometheus up before the node exporter. And also I'm going to be putting the node exporter on the other boxes. So don't forget that. Maybe I should put it on Fitchner anyway, just to have another scraper. I don't know. I'll debate that here in a second. But let's go ahead and bring up the node exporter site because we're going to need that here in a minute. Copy link. Paste and go. No, I do not want that. I want... What? Why are you failing me? Prometheus. Node exporter. And you go to releases. Here we go. Now we're getting somewhere. And our ARM7 release is right there. Okay. So all right. So we have Prometheus here. So if I go into Prometheus directory, I can go Prometheus, just do a /Prometheus. The CPU has no floating point hardware, so it cannot run. That is new. I have never seen that one before. Tell me someone else has said that before. Raspberry Pi. Oh, interesting. So this is a legit problem. Okay. So let's hop out of here and delete that, and let's try Prometheus. Oh, I also grabbed the FreeBSD version. Haha, my bad. So let's try the Linux one again. Copy Linux one. wget. Pull that down. Install in Prometheus. There we go. tar xvzf Prometheus. There we go. Okay, looking better. I don't really know because obviously I haven't actually done anything yet. If I go /Prometheus. There we go. Okay, so as you can see, Prometheus came up and ran. As you can see, it's a bunch of garbage on the screen, all these fun little stuff. But the most important part right there is that final line, the main.go server is ready to receive web requests. That means we now have a working Prometheus server. Making progress. Okay, so Fitchner now can receive Prometheus requests. Obviously, I want to stop that because I still want to do some stuff inside of it. But if I remember correctly, I should be able to just actually hit it immediately. Hang on. So let me just go ahead and do that, and then Fitchner. Yay. I should have really written these IPs down. 152. 152. Nothing there. Is it 9090? I think that's right. There it is. Cool. Okay, so now with running it, we are receiving actual requests. We can go over into, there's a way to actually see, is it graph? No, it's not graph. It's not alerts. Prometheus actually reads its own self. Is it metrics? Metrics. There we go. So actually Prometheus actually creates metrics for itself about stuff. And I was reading recently, or watching a video about this, and there's an actual counter down here. Web flushes total, is it that one? That feels right. So if I actually search against this one, execute. Yeah, so if I just refresh this, no, that's not it. There's a way to see Prometheus web HTTP. There's a request way of doing this. I forget what it is off the top of my head now. Shit. Okay, well, the point being is that there's a way to actually get Prometheus to give you the data. But you know what we're going to do now? I am going to install the node exporter on Fitchner to start talking to itself. And then I will go to the other 3 machines and install the node exporter into that to give it to Prometheus. And I'll get Prometheus to set up a little bit better. Just because that feels like the right thing to do, so I'm going to do it. Alright, so if I come over here, and I am now doing the node exporter portion. I don't need this side anymore. Don't need that anymore. Where'd that go? No. No. There we go. That's the one I was looking for. So I come back over here. And I need to do the node exporter. So this one suggests me doing it inside of opt, interestingly enough. Just because I figure, is there anything in opt? Oh, there is actually. It's all done by root though. I don't feel right with that. So what I'll do is well, you know, no, because I actually do need root access because I'm doing actual hardware. Like I'm actually getting real information off the hardware. So maybe I should do this under opt. So here's opt under Fitchner, and then I will grab the node exporter under the releases here. ARM7 of Linux, copy link location, wget, and then I will paste that in, and there it is. And then I come back over here and I go tar xvzf node exporter. There is the node exporter, which I was hoping for. Good. Okay. Then the next portion is I need to interesting. It just tells me to use the nohup node exporter command here, and then run it in the background, and then it'll just start dumping or dumping stuff to 9100, and then I actually have to use IP tables to allow it to work. Oh, that's gross. So first of all, I don't think, is that my actual IP or my, oh, it is ETH0. Okay, cool. So I know a handful of Linux versions have moved away from calling NICs ETH0, and they've called them some really crazy things. I miss the days of ETH0. I feel like that could be a good t-shirt, but whatever. It was a good joke, right? So let us go ahead and do nohup node exporter, push that into the background like it says here. All right, so that looks like it's going. So if I go ahead and grep for node exporter. And there it is. It's up and running, which is what I was hoping for. And then I will do these IP tables here. Didn't like it. Let us see. Oh, it's because I shut it down, isn't it? Crap. Okay. Okay, so what I'll do is I've got it running. IP tables is probably stopping it. But what I will do is I will go back to Prometheus. And then I will vi prometheus.yaml. And then don't need to worry about the work manager. Okay, so just because I will change. I need to do, that's the local host, so exporter nodes scrape of this. So I will dump this out over here. Paste. And of course it's not how I wanted it to be, because that would be very easy. Put that under vertical column. Damn it. Alright. This goes underneath. Really? That there. That there. And then static configs goes there. And then targets goes there. Okay. But then this actually is going to be. Oh, great. That needs to be that. Needs to be that. If you didn't notice, there was those weird fake ticks. It wasn't the actual ticks, so it would get angry from that. But I'll do localhost there. And then that. And then that. Okay. Now I'm going to go here, make another space here because that looks gross. And try it that way. Okay. So if I do /tmux, is tmux already installed on this? It is not. That would be too easy. Tmux ps sudo apt-get install tmux. Yes. Installing tmux on here now, which is nice. Getting there. I said yes. Go. Make install. Not make install. Haha. Another fun joke. So get tmux on there. Spinning up these machines. Making things happen slowly but surely. Alright, so tmux is now there. There we go. Okay, now we're in tmux. I can go to /Prometheus. Oh, something did not like that. Line 31. Alright. So this is where I'm going to bring in Emacs. And I'm going to go to /ssh pi at 192.168.1. What was this one? IPA 152. 152. And then go to Prometheus. Arm 7. Prometheus. There we go. Okay, so it did not like line 31. Line 31. Okay, as you notice, the color's off. No, it's not. What? Job name. Static configs. Static configs is under that. There we go. And then embedding that. Good old YAML. Oops. So Prometheus, still not node client 31. Alright. Good old Google. So, oops. Prometheus.yaml. Oh, of course you thought it was a website. Stupid thing. Prometheus YAML. That is just the actual example YAML that I had in the thing. Alright, so node exporter, there we go. That is totally not what I'm looking for. Oh, here we go. Object nodes, or nodes. We can take out, let's take out the scrape interval for now. And then, it's because it was the wrong dash. Just like the ticks earlier, this one had the wrong dashes too. That's frustrating. Okay. So I'll go back to this. Still didn't like something. Line 37. Unmarshal errors. What the hell does that mean? Oh, again, it's the wrong dash. There we go. So, if we go back over into this guy, and we refresh Prometheus, we should go to status. No. No. No, that's not what I'm looking for. Configuration? No. There's a way to see all the different targets. There it is. So now targets. So it did not like. Was it doing every minute? Oh, it's doing every minute. Ugh. Alright, so we gotta wait for a second here. For this node to come in as localhost metrics. If I'm right, I should be able to go here. I don't think that's working how I want it to. Yeah, I should probably put the actual IP in. This doesn't feel very, what's I'm looking for? Flexible, does it? Alright, let's try that again. 192.168.1.152. Write that out. And I will kill that. Start that back up. Oh, it could also be the IP tables. Oh, it probably is the IP tables. 192.168.1.152. Oh no, so 152, that worked. Getting actual data now, that's good. So if we refresh this guy, instance of that, still hasn't actually done it yet, so I gotta wait a minute. But we didn't actually need to do the IP table stuff, which is good. That allows us to see something. So, Keep going. It's doing its thing. Come on. There we go. Awesome. So now we actually have Prometheus now monitoring itself. I still don't have InfluxDB or Grafana up and running, but I now have Node Exporter exporting data out to Prometheus. So let's take that next step farther and go to there we go. So I detached using Tmux. So I have that process running, so I still have it here, which is good for obvious reasons, which is good. There we go. What I'll do is I will go over to Mustang now, and I will sudo up to root, cd into opt, and I will go back to my node exporter here for Linux on ARM7, copy link, location. I should probably turn this into a script so I don't have to keep doing it, but whatever. wget, I can't spell wget, wget. Now it's coming down. Okay, tar xvzf, node exporter. Go back into node exporter here. Because I'm lazy, I will take that exact same command with no hop of node exporter here. Okay, so if I go back here, I do pswx.node exporter, and I see node exporter. That's good. So I can go back to IPA, and because I still have the file open here, if you've noticed, because I am thinking ahead, I can go over here, take that, and then do this one, comment this one, comment this one. So Mustang is actually IP grep 192 of 153. So there we go. So I can go from IP from Mustang to Darrow sudo root, and then go back over here. Like I said, I should turn this into a script. Node exporter of ARM7, copy link, wget, this guy, tar xvf, node exporter, go into node exporter, and then go back to the hop command, copy, paste, and then if I do IPA, I should see IPA grep 192, 154, so that's 154 here. There we go. And then I should be able to go over to Sevro, sudo su, wget, back over here, copy link location, wget, and paste. If you were doing this in more so than just 4 machines, you should probably be using some type of automation like Chef or Ansible. I did not, obviously, because I'm doing this live and trying to just get this to work, I'm not doing this by that way. But needless to say, if I have to rebuild this thing, I will spend the time to do the actual writing the playbooks or the cookbooks to do this. I can open source those too. If anyone's actually interested in collaborating on working on those things, I would love to collaborate and get that going. I used to do this stuff all the time when I worked at Chef, so it wouldn't be too hard to get up and running, and we can make something pretty useful out of it. A nice little Raspberry Pi, a nice K3s cluster cookbook for both server and agent, and it can be compiled on Raspberry Pis would be really, really cool. Because then you can just like do one cookbook or one playbook, and all of a sudden everything's done. But that's a project inside of itself, and I'm not going to do that quite yet, as I said, because I'm just trying to figure out how to get this working. So there we go. Then I'll take this node exporter, and I will paste it. And then do IPA, grep 192, and that's 155. So this should become 155 now. And then there we go. So my theory now is if I go back to Fitchner, tmux a, go back to this guy, shut it down, bring it back up, and come back over here, and then go back into Prometheus and then refresh it. There we go. So as you can see, it's scraping now the 3 endpoints, which is good. I need to figure out a way to, maybe I'll add that to the DNS or the H, because I don't like having the endpoints within IPs. I need the names. So that's pretty cool. I've been going on for about an hour now, and my throat's about to kill me. So I'm gonna give a 5-minute break, and by the time I come back, these should have scraped, and we should actually have some data. And that'll be interesting. So thanks so much. If you come back, or like I said, I'm gonna do this for about another hour afterwards. Now that I got Prometheus up, I'm planning on getting InfluxDB and Grafana next. So then I can actually have the full monitoring solution, and then have that 3-node Kubernetes cluster, and then maybe I'll inject some pods into the Kubernetes cluster to see how that goes. But again, I'm just trying to getting monitoring solution up and running today. But yeah, thank you so much. And I'm going to put my little screen up to say I'll be right back. And I will be back maybe in about 5-6 minutes. All right. Thanks so much. Hello. So yes, I'm back. If you stuck around, thank you so much. If you're just joining us, um, thank you again for being here. I've spun up a Kubernetes cluster on 2 or 3 Raspberry Pis, and I'm now getting monitoring up and working on it. I went ahead and added into the Prometheus just a few moments ago. As you can see, they're here. They're still unknown. I wanted to wait till I got back on before hitting the button to refresh, and yay! There we go. Sweet. So we are actually getting real metrics into Prometheus now. I can do some fun little graphing things and stuff like that. But again, like I was saying a minute ago, I don't like having these endpoints here. So what I'm going to do is I'm going to go into actually Fitchner and add these IPs to his Etsy host file, which will be a problem in the long run because I'm actually in the process of moving my network here soon. And I don't think these IPs are going to stick around, but for the time being, that's okay. So let's go ahead and do this now. So if I go into here and then I do sudo vi Etsy hosts and bring this back up over here, I will go into 192.168.1.152. Oops. Cannot type. Nope. 152. So 122, and then I'll do 53, 50. Oops. 54 and 55. So if I got this right, Fitchner. There we go. And then this is Mustang. And then this should be Darrow. And this is Sev, bro. Now, you should never do this in production. You should never be editing Etsy host files in production. If you are doing it wrong. DNS exists for a reason. Granted, 95% of your problems will always be DNS because it's DNS. But because I'm just running these on a handful of machines, and I feel I can touch every single one of them, it's not that big of a deal. I really should take these and actually put them on the other machines too, but I am lazy, so I'm not going to. So if I do this, and then I come back over here, and I change this guy to Fitchner, and then this becomes Mustang, and then this becomes Darrow and Sev row. I should be able to restart this. Nope. Restart. Restart this. That should come up. And I should be able to go over to this guy and refresh him. There we go. So now I have actually the host names inside of the targets. So when I start searching against the targets, I'm not going to be going off the IPs, I'm going to go off the names, which should make life a little bit easier. So let's just give this a minute to make sure everything scans properly. So let's see how it's going. Refresh. We got 1, we got 2. And we got, there's 3. So let's go back to it. It's actually on Fitchner. Okay, so let's see Severo show up. There we go. Severo has shown up now. Okay. So remember, we have a Kubernetes cluster using k3s on Darrow and Severo and Mustang. Mustang is also the server. So she's controlling Severo and Darrow. So now that we get actual data sent into Prometheus about these machines, that's helpful. But we need, Prometheus is not designed to be long-term storage. It's just not. It's designed to be short, like just basically a router of information. So we need to now get something called InfluxDB, just because I like InfluxDB because I finally got my head wrapped around it, and something called Grafana on top of it. When we get all that on top of it, then we can actually bring up a dashboard of the health of our Kubernetes cluster with all the different information what's going on. I know Kubernetes comes with some of this information too, but if you're actually doing this in the real world, having the actual stats of the machine against what Kubernetes thinks is going on and be able to cross-reference things and be able to actually see the full health of the system can be extremely advantageous. And that's what I'm trying to get across here. So let's take it to the next step. Okay, so we got Prometheus, and then we reload, that's fine. And now let's get Grafana set up on here. Okay. So this is on Fitchner. So what I'll do is I'll go to a new one here. mkdir Grafana. Oh, interesting. Okay, so this one doesn't actually use InfluxDB. It just takes directly from Grafana. That's not what I was expecting. That is really weird. I was not expecting that at all. But according to this, it looks like it's fine. So let's just do it that way then. I'd be really curious to see for long-term storage, but again, as you can see the node exporter here, we're going to see so much information about what's going on and how the machines are. So let's go to Grafana. Grafana. Yes. I need to download Grafana now. Maybe. Possibly. Just thinking about it. Come on. Show me some love here. Grafana. Come on. There we go. Okay. I need to download Grafana. Get Grafana. Why is this so slow? Get Grafana. Just thinking about it. Maybe. Get Grafana. There we go. Download it. I want to download it. There we go. Jeez. Why is it so slow? And we need an ARM one. And I need ARM 7. Nope. Stop it. Stop it. Stop it. I need ARM 7. So I'll cd Grafana wget. Of course, that didn't work how I wanted it to. Copy that. Paste that there. Pulling it down, sudo dpkg-i Grafana. It's installing, which is good. And then I should be able to go. Yes, I want to install it automatically. And then I want to actually start it. Yes, thank you. So then I should be able to go to port 3000. I knew that. 192.168.151.3000. There we go. So now we got Grafana up. It's actually loaded. Admin, because, you know, security. And no, I don't want to change that password because nobody should ever reach it. Okay. And now I need to add some. It used to bring up the little, how to add the little thingy bobbers, data sources. There we go. Do I have InfluxDB still? TSWX graph influx. I don't. Add a source. Prometheus. Localhost of 9090. Don't care about any of that. Save and test. Bad gateway. IPA. It's 152. Oh, it's 151. Oh, it's another box of mine. Ha ha! My bad. My bad. Oh, that's what happens. Admin. Admin. Don't save. Skip. There we go. Here we go. That's more like it. That's what I was looking for. Okay. So then I go to Prometheus. And yes, localhost. Test and save. It is working. Yay. Okay. And then home. Then I need to do a dashboard. There was a pretty good example dashboard here. Dashboard of 1860. There we go. I need to add a dashboard. Import. There we go. Discard. 1860. Load. That's what I'm expecting. Prometheus. Import. And there we go. Now we get really pretty graphs of everything from Prometheus on what's going on the different machines. As you can see, though, it's been the last 24 hours, so let's change it to the last 5 minutes. And that should give us something? Anything? Fitchner? Here we go. So Fitchner has had some stuff happen. It's not that bad, actually. Severo, how's Severo doing? Severo's doing okay. Got some metrics. As you can see, it's not pushing too hard, which is good. His CPU really isn't doing too bad either, but I don't know why Dara wasn't doing. There we go. Dara's doing something now. So, as you can see, we have pretty good data now of our little Kubernetes cluster. So Darrow and then Mustang is our server. We can imagine her being a little bit heavier, overwhelmed. But I can now take some of this data and at a later date, I can pull all this apart and then actually have like a single dashboard to be like health in my Kubernetes cluster and get all that information. So that's pretty cool, right? Like I totally have monitoring now on a Kubernetes cluster, which makes life so much better. And it all comes from a 4-node little Kubernetes thing. Okay, so now that I've gotten this up and running, so I have local monitoring. I can saw the health of my targets. Everything's going well how I expect it to. I have Prometheus and Grafana installed and k3s. I can set up some alerting and all that jazz, and I can do that at a later date. Right now, I don't feel like doing that. I'm going to go into the Razzie stuff. So Razzie is k3s. No, that's not what I wanted. I want to do a folder. k3s. Because I will lose all these links at some point. I'm going to go ahead and put them in here. k3s. And you. And you. Perfect. Okay. So, next thing is I'm going to get k3s installed, or I'm going to get k3s installed on a Kubernetes cluster I've spun up inside of the IBM cloud. and get something called Razzie installed on that. And then I'm going to install a specific container into our Kubernetes cluster that we just built now to be able to talk to K3s. So, or talk to Razzie, so we can actually start monitoring, and I'll be able to use Razzie to change resources on my little Kubernetes cluster. This is the stream I want to do tomorrow. I was not expecting to get to this point so quickly, which is pretty cool. So I'll spend that hour or 30 minutes tomorrow doing that actual continual deployment and continual integration of the resources there. But this will be the setup to be at that point. So next thing I need to do is I need to come out to here, and I'm going to be going to, Razzie.io. This is a multi-cluster continuous delivery tool for Kubernetes. This is just been released by IBM, and it can control K3s clusters, which is pretty cool. So if you have a lot of edge computing, the edge computing story of using K3s, which is one of the large things they're trying to push for, this is a way for you to control multiple Kubernetes edge clusters, so IoTs, things like that. So you could actually have Razzie orchestrate rolling out new resources to it, and that's what I'm planning on emulating tomorrow. So if I go ahead and grep for my new cluster, let's see if it's up and running. And I called it Razzie, and it was built an hour ago, and it looks like it's doing good. So cluster config, and then I put that there. And there we go. And I export out my cluster config to this guy. If I do kubectl get nodes, I should be facing to my external one now, and I am. Awesome. It's been up for a little while, which is good. So we're making progress here. I need to go to the GitHub page. So what I will do now, so what I'll end up doing as soon as I get Razzie up and running, which I have not done yet, as soon as I get it up and running, I'll install the Watcher Keeper component onto the K3s cluster that we created, which will be able to talk to this cluster. But we need to get Razzie up and running first. Okay, so I just realized I guess GitHub would be the Git repository. And it's not really true, but whatever. Okay, so let's install Razzie first. So I pull down this resource. Okay. I like doing this stuff twice just because sometimes things go funky on us. And then if I do get pods to make sure everything's up and running. And as you can see, it is nowhere near everything that the output should be. There we go. Now we're getting somewhere. So it's starting to build stuff up now. And obviously that is really hard to read, so I'm going to stop that and go back over here. And everything looks like it's running. Remote controller resources, resource 3, yep, that looks like what they were saying was going to be there. That's good. Then I'm going to store the components. Right, that. Creating some MongoDBs over here. Make sure everything's what we expected. As you see, there's a persistent volume that needs to be created, so for whatever reason it needs to be reconfigured. Again, I guess it's not idempotent, that's weird. Okay. And oops. All right. And still waiting for it to start. It's going along slowly but surely. Dom ASXD, are you doing this for the company of yours, or are you doing it on your own personal servers? So that's a great question, Dom. So I have a Kubernetes cluster that I built off of some Raspberry Pis, which I showed earlier on in the stream. It's basically three different machines here. If you see here is one of the machines here, PSWX uname-a. As you can see, it's an ARM7 box here. I have 3 of them. If you go to SSH Mustang k3s kube cuddle get nodes. So what I did is I installed something called k3s on 3 Kubernetes clusters, or 3 Raspberry Pis. And what I'm doing is I'm now installing something called Razzie onto a IBM Cloud server, or Kubernetes cluster, sorry. Razzie on a Kubernetes cluster, which I'm going to get, and this Kubernetes cluster that I have on my local machine, which is on these Pis, I'm going to get to actually talk to the Razzie instance. So when that happens, that means I'll be set up for tomorrow for my stream, which I'll be able to, or the stream for the hackathon we're doing tomorrow, where I'll be able to use Razzie to do continuous deployment to my k3s cluster. Hopefully that answers your question, and if you have any more, please don't hesitate to ask some more. I'm doing these on my own personal machines right now, and I'm using my IBM resources because I am an IBM employee on the IBM Cloud. Hopefully that answered it. Cool. All right, let's see here. Oops. So if I come back over here and I look, it is still initializing. That's unfortunate. Container configure. That's new. All right. So Dom, your next question was, so this seems pretty neat. What's the end goal of this project? The end goal of this project is that I want to be able to use Razzie, which is this open source project from IBM, to control k3s clusters. And if you didn't see k3s earlier, this is k3s. It's a lightweight Kubernetes that's a binary that only requires 512 megs of RAM, which, and interestingly enough, is perfect for a Raspberry Pi. Using this, I'll be able to do, the theory being is that IoT or edge computing for Kubernetes, which I can use Razzie to orchestrate. So imagine you had a factory or something like that, and you had a bunch of sensors on Raspberry Pis, or the equivalent of a Raspberry Pi or ARM processor, all over your factory. And you needed to update your software on those sensors to do something, or add a new feature because you added a new sensor to it or whatever. And you had hundreds of these, maybe even thousands. Spending your time and effort to roll that software out to all those different sensors could take so much time. The theory being is if you added a new temperature sensor to this or whatever, and you had k3s on there instead, and you had Razzie orchestrating all those k3s clusters, then you could do a canary deployment using Razzie. In turn, being able to do 10% of all your machine or all your Kubernetes clusters or k3s clusters could get the update, and you can actually see if the data comes in properly. And then you do 20%, or you do it all at the same time, and you'd have the ability to orchestrate this in such a large way. And this is a proof of concept in a very small aspect, obviously, but it's enough to be able to say that this could revolutionize the way of getting true IoT out there. It just is a natural progression, because what is Kubernetes other than a container orchestrator? Hopefully that answered your question. Dom, if you have any more, don't hesitate to ask. And it is still config creating error. Okay. So KTL describe describe pod. Describe. Oh, jeez. Why am I forgetting the commands? Kubectl describe pod, yeah. Describe pod. Why am I doing that wrong? Oops. This describe pods. There's a pods. Oh, is it really? Ugh. I cannot type. So Dom, you followed up by, well, this project of yours seems to be focused on only updating Raspberry Pis and sensors, then if I understand this correctly. So as a proof of concept, yes. I'm doing a POC of the ability to do, using Razzie, to update the Kubernetes cluster that runs on these Raspberry Pis. So it still requires running K3s, lightweight Kubernetes. So I have Razzie controlling, or here, let me bring over the, maybe if I use my hands in a weird way, it might make more sense. So give me 2 seconds here. Okay, so imagine you have Razzie right here, which is your orchestrator, your Razzie right here. Then you have a bunch of Kubernetes clusters around here, which are all right now running on Raspberry Pis with K3s. You have inside of that Kubernetes cluster, you have some Kubernetes or some application running in a container, and you have some sensors attached to all those different Raspberry Pis or whatever IoT that is running K3s. My proof of concept is the ability for Razzie to be able to control the containers that are all installed on all of those Kubernetes clusters. So if you have multiple Kubernetes clusters, like around a factory, for instance, which is the use case that I'm using here, and you install like a temperature gauge or a temperature sensor and a humidity sensor on every single one of those Raspberry Pis or IoT instances around your data center, you would physically have to get someone to go out there and plug in a temperature gauge, right, or a temperature sensor or a humidity sensor or whatever. Then you'd have to update the software on the actual Raspberry Pi. But if you're running something like K3s on there that's being ran by Razzie, the theory is you can have the code that Razzie is continually looking at around the cluster, or around inside of each of the Kubernetes clusters, and be able to update all those different sensors as soon as everything's installed and comes back up online. The ability would be so much more velocity for something like a factory and for sensors or for IoT in general. Again, this is just a simple use case, but it's enough to be able to prove putting these three different technologies together, Razzie, K3s, and IoT and or Raspberry Pis and sensors, and something running inside of it, which I'm using a temperature sensor as an example here, that's enough to be able to say that this is a well worth project to spend some time on. Hopefully that answered your question. If you have any more, don't hesitate to post something else. Okay, let's see here. And again, this is not doing what I expected it to. I did actually see this Razzie Dash problem one of the first times I ever installed this thing. I have spent some time with Razzie since, what was it? KubeCon Barcelona, where we actually announced it. So there is, oops. Let's see here. So Razzie Dash API is up and running. That's good. Oh, That's everything we wanted. Okay, cool. So I guess for whatever reason, it just took a little bit more longer than we were expecting it to. Let's see here. Okay, so that is running. So here is my Raspberry IP, and I'll take this again. Okay, and then I will create a config map of these two. Okay, and then make sure everything is in a ready state. Nope, that did not work how I wanted to. Reset. Okay. Everything looks like it's in ready state too, which is what I'm hoping for. We're getting somewhere. No, your Razzie Dash is still not in ready state. Why is it not in ready state? Okay. Let's see here. Everything's running there. Razzie Dash is up and running. Now everything's in ready state. There we go. So Razzie Dash just took a minute to come up. It's a good sign. Okay. And I need to see, so I need to echo $Razzie-LB this IP and port 8080. There we go. We got Razzie Dash up. Well, it's coming up. There we go. Okay, so we got Razzie. So let's sign in. I need to configure a GitHub login. Okay. So we're going to do Razzie HTTP port 8080 HTTPS callback URL is this guy. Paste that in there. Register the application. And then the client ID is this one. And this one. And if you decide to abuse this, that is your loss. I will change these tokens as soon as I'm done here. Save configuration. Sign in with GitHub. I want to authorize this, yes. And then I'm going to register with CoffeeOps, which is the org that I use. Okay, so we now have Razzie Dash up and running, and I'm going to take this now, and I'm going to go back to my so Dom, you asked another question here, which is, oh, now I understand the concept. It sounds like it's an interesting project, which I would like to do myself. Any other ideas where multiple raspberries could be used? Well, that's the beauty of this, is I don't really know this is just a proof of concept, right? And this is anything that can run K3s. And as you can see, K3s really does have quite a few. It's just a Go binary that's an orchestrator to run. Run containers. So anything which, as you can see, can run 64-bit, x86, ARM7, or ARM64. Anything you can run those things has the minimum requirements here of this, which is only 75 megs per node, right? Think of it that way. And then it can run this, can run that binary, and then you put a container inside of it, it would just work, It would just be able to run. Again, I spent a long time trying to think of a really good use case for this because I know there is something extremely valuable here, and I didn't want to get too lost in trying to come up with like a really awesome idea. This is just a real simple one that I can get off the ground and maybe even do some demos at conferences and things like that, where I can start doing some ML or some AI or machine learning on identifying some things. I found some really awesome machine learning tutorials on using the camera for the Raspberry Pi and doing and processing and creating new what's the word I'm looking for? Inference documents or whatever the term is. So you can actually, in theory, take a bunch of pictures with one Raspberry Pi and then ship all those pictures after they've been sorted as possible X, Y, or Z into the Kubernetes cluster, and then let the Kubernetes cluster actually do the processing and then ship you a new inference document, which in turn send back to the original Raspberry Pi, and you get more data. That's just one of the other ideas we've come up with. But this one is just a simple one. It's something that factory people who run factories could actually really use if they started going down this path. Okay, so where was I? So I got Razzie up. Just to show you Razzie here in a second. As you can see, nothing is actually running inside of Razzie because it hasn't actually done anything to itself. I can go ahead and do it, install it to itself, which I will do. Kubernetes, kube cuttle get nodes. So I can do that. So what I'll do is I'll create I will install this, which seems like it did something. There we go. So now Razzie Dash is actually looking at itself. As you can see here, I have a version 1.13 cluster. No active deployments because it's still getting the data, which is fine. And it has one cluster right here. So as you can see, it has a bunch of names. And again, I'm only showing the very basics of it here today. I've only got about 15 minutes more before I need to get off and go do some other stuff. But I will be streaming again tomorrow where I do more of the advanced, or I should say I'll be trying to figure out the more advanced Razzie stuff. We just had a Medium article posted about doing it, and I figured it'd be fun for me to try to figure out it live. But I will, as you see, got the one seeing Razzie doing itself. But what I want to do now is if I come back into .kube, and then I do copy, or what is it? Unset kube config, right, echo kube config. So I want to unset kube config. So if I do that, I should kube get nodes. As you can see now, I am now looking at my local Kubernetes cluster, or my local K3s cluster with the 1.14.1. And as you can see, this is 1.13, if you can see really small, which is the actual one running on IBM Cloud. So the theory is I should be able to go to this guy. There we go. It's actually doing so. It's actually getting some data now. If I go to manage here, and I take the Razzie agent, which is also that worker that I was talking about a moment ago, and post that here. My theory is I should see a second one in a moment. Okay, it's getting there. I'm going to do it one more time, just make it on the safe side. Okay, so we got it. We got everything because Kubernetes is idempotent. It has been like everything's already here. I don't need to change something. Leave me alone, which is fine. But if I go ahead and refresh this guy, I should see 2 clusters. Maybe. thinking about it. It's thinking about it. We'll see. We will see. All right. Well, the Kubernetes cluster in general on a Raspberry Pi is not exactly the fastest thing in the world. But if we go to the so if I do Kubernetes or kubectl get pods namespace Razzie -- name space. So it's pending. So it's still trying to find a place to run it. That's okay. That's fine. That's the reason why we haven't seen it yet. Watch. So let's just watch this for a minute. I'm gonna go ahead and go on mute for a second so I can drink some more water because my voice is starting to kill me again. I'll be back. As you see now, it's container creating, so it's actually pulling the code down from the internet onto one of the Raspberry Pis that is considered one of the worker nodes, which is good. But it's not going to be done until basically it says it's running. So let's give it a couple more minutes here. And I'm going to turn this on to refresh, auto refresh, because I am curious to see how this goes. As you can see, it pulled in a bunch of data here. I'm really curious to see where it's going to end up. Severo doesn't look like... Oh, maybe he is going to be the one. Maybe it's going to be Darrow. We'll find out here in a second. I think it's going to be probably Mustang at the rate we're going here. She looks like she's doing most of the work. And still container creating though, unfortunately, because, you know, it's running on a Raspberry Pi. But that's still worth taking a look. Let's see here. Come on. I wonder if there's any Grafana. Grafana dashboard Kubernetes. Oh, and there's also a. That seems reasonable. 6. Oh, but I don't actually have any Prometheus. Oh, that's pretty close to what I'm looking for. Let's see here. It does take it from here. This does not require you set up the Kubernetes app. This Helm chart is launched for that. So it's still creating the container. I'm going to go again here on mute for a second. Still creating the container. It's unfortunate. Just to verify again here, it's container creating. It's taken 5 minutes now, but that's okay. That's okay. That's fine. That's what we're expecting. So what I'm thinking is happening here is that I think the container actually gets shipped into. Yeah, it looks like it gets shipped into the server first, which is Mustang, and then she ships it off somewhere else. But I don't think she's actually shipped it anywhere yet. As you can see, it's still container creating, which is interesting. But it's going there. So, and let's see if Razzie Dash obviously hasn't done anything yet because of the container still being created here, and it only really has one resource because there's nothing else running on here apart from Razzie Dash. Or Razzie, I should say. Well, as you can see, it's still running container create, which is unfortunate, but we can't really do anything until we can see it pop up inside of Razzie. So I'm patiently wait for it here. You'll see me click around here on the left-hand side, trying to find good container or Kubernetes monitoring. If anyone has any suggestions, I would love to see it inside of the stream chat, because I'm actually, like I said, I'm doing this live. I have not done my research yet, and this is me figuring it out. So if you have thoughts or suggestions, I am more than happy to hear it. I'm betting I'm going to need a Prometheus plugin to talk to the Kubernetes cluster. That was kind of what this guy is saying here, but it says that it doesn't need it, so I don't fully understand this. So I'm gonna, like I said, poke around and go some stream of conscious, and I'll go on and off on mute here, just because I'll be processing a lot of this stuff. All right, because I'm a completionist here, so I'm gonna let this continue to run and keep the stream going. I was only planning on streaming to the top of the hour here because, like I said, I had some other things to do. But I am very, very, very annoyed that this has not completed yet. So I'm gonna keep this going and do some more research. But no matter what, I have to end in the next 30 minutes because I have, like I said, other responsibilities. But if anyone has any questions or thoughts, please don't hesitate to post them inside of the stream chat, or you can tweet at me. My Twitter handle, or my Twitter name is JJ Asgar, just like my stream channel. And I have no problem with answering questions or thoughts or whatever. And as I was saying earlier, I do work for IBM, and my job is Kubernetes evangelism, and I'm looking forward to learning more about this stuff as I'm going through it. And yes, as you can see, I take a lot of pictures of meat and bread because that's one of my passions, is to kind of go through that. So again, I just kind of want to throw that out there again to see if anyone's interested. There's probably a better monitoring solution for actual internal Kubernetes into but again, even though that a K3s cluster is a full Kubernetes cluster, I have this gut feeling I need to do a way to scrape the server to send the data to something like Grafana. It still hasn't really shown me where this... Oh, here we go. There's things actually happening here on Mustang now. Who is she sending it to? Sever doesn't look like... I think it might be Darrow. No, I think she's going to run it herself. Makes sense. There's nothing else running on this cluster. So... it's going. I got a lot of blinky lights over here too, which is nice. Let's see here. Create a Grafana dashboard. Hey, it was even from IBM too. That's useful. Oh, but I don't actually want to monitor the Razzie. I want to monitor my local Kubernetes cluster. Deploy InfluxDB and Grafana on Kubernetes to collect Twitter stat. That just seems like more problem, or I guess it makes sense, but jeez, that's a lot of work. Maybe just straight Kubernetes inside of the glabs, maybe? Don't know. Node exporter. Kubernetes. See, a lot of this stuff is actually internal Kubernetes. I want to find like the health process of a Kubernetes cluster. And I don't have any way. I should. You know what I should do? I should figure out how to get Kubernetes ship stats to Prometheus. So I'm not looking to use Rancher to do this. I want to build it myself. Because there's got to be a way to just take the data from the deployments of the Kubernetes. I like the idea of doing it in 15 minutes. Let me look at that one too. What is Prometheus? That's great, whatever. I don't care about RBAC. I don't care about deploying Prometheus because I already have it. Excuse me. That's all a bunch of data about it. That's fine. Again, you're just doing stuff internally to Kubernetes, which is not what I want. I guess I should do an operator. Service watch. Yeah, that's what I want. Because I want to do Prometheus monitoring services and deployments beside managing or managing refined configuration. Okay. And create a CRD named a service monitor. How Nginx. I don't want to do. Not exactly what I'm hoping for. Alright, let's see where we at here. We're Still doing container creating. 16 minutes. Jeez. Still going. This is not exactly what I was hoping, but it's fine. Yeah, I think Severo got it because his RAM's skyrocketed compared to... No, that's a... Well... Darrow 2. I really have no idea. I really don't. I was at a conference relatively recently. Somebody was talking about a container they could just throw in to their Kubernetes cluster, and it would start getting, if you did in privilege mode, because obviously you need privilege, you would get a lot of really good data out of it. I did write it down somewhere, but I did lose the actual piece of paper. So I'm really annoyed that I can't find that one right now. There's got to be a good answer here. Monitoring Kubernetes with Prometheus is what I want to do. Friends at Sysdig, huh? Yeah, that's what I want. I want Prometheus to scrape Kubernetes API for now, and then I want Grafana to pull from it. That's exactly what I want to do. So I've installed Prometheus. That's fine. Don't need to create a deployment because I already have it. Here we go. How to monitor a Kubernetes service with Prometheus. Install traffic. Kubernetes service. You install traffic deployment Prometheus. I don't want to set up Prometheus. I already have Prometheus installed. How to ship contents over to it. Install the traffic endpoints and crap like that. Git clone. Wait, what? It's likely many applications you don't deploy Kubernetes could not expose Prometheus to the box in case you plan to Prometheus exporter logs, blah blah blah. Clone down this monitoring guide. Do Prometheus exporter inside of it. So what the hell does he have in here? Google. Let's see what he's got. Prometheus server. No, it's all the stuff Still just generic stuff. How do you get a health? Oh, here we go. Monitor kubernetes as Prometheus. Kubernetes can be monitored, pointing tools. Oh, it just is actually what I've been doing. State metrics. What are state metrics? Add-on agent to generate and expose cluster level metrics. It's a simple service that listens to the API cluster and generates states about the state of the objects. Metrics below. Why are you? I think this is what I want. So I need to figure out, again, you just need to script the service port 88 and Prometheus config. Remember, use the FQDN this time. But I'm not, because I'm going to do it externally. Okay. So repo. So I'll pull down state metrics. Oh, that's new. Kubernetes, get pods. No resources found because that's expected. Okay, so I should be able to go into Kubernetes, get Patrick, okay. I need to apply all of them. That's not an actual thing. Kubernetes. There we go. Oh, haha, my bad. So kube get nodes. Make sure we're still talking the correct one. Yep. So then I can do kube cuttle apply -f Kubernetes. Okay. And then kubectl get svc and kube system. That's not there. Kube matrix, there we go. So no external IP. How do I curl PA? Yeah, I thought it was too easy. Okay, so I have it working. I have no external IP, and I have no way of getting. How do I get the data? But aren't I already getting that data because of node exporter? Port 8080 tricks. No, that would have been too easy. Still container creating. That's unfortunate. I will keep it. I'll keep an eye on it over, I guess, today, the rest of the day, because can't really do anything else until this gets done. Which is unfortunate, but that's okay. Thank you again for joining me. Hopefully you all learned something. I'm gonna take this exact same video and upload it to YouTube here in a little bit, because I feel like it might be worth time to have this out there too. I did walk through installing k3s on 3 Raspberry Pis, 1 server, and 2 worker nodes. And then also I installed Prometheus and Grafana on a observer monitoring node, all on 3 or 4 Raspberry Pis, named after characters from the Red Rising series. I'm going to be back again tomorrow on the IBM developer stream, 24-hour stream, where I will be attempting, hopefully, that Razzie will be done by that time, or figuring out what's going on with Razzie. Maybe I can get someone from the Razzie team to help me figure out why this hasn't shown up yet. Because it has worked. I have actually gotten to work. I just don't know why it's taking so long now. So, with that, thank you so much. And I will hopefully see y'all tomorrow.